Today's topic is simplifying and approximating square roots. Today is April 21st, and this is the note packet that you'll need for today's lesson. So yesterday we talked about perfect squares. We know that if you have a perfect square and you take the square root, you're going to get a rational value. That doesn't always mean a nice whole integer or a whole number. It could be a decimal or a fraction. Not all square root radicals are perfect squares. So if the value of n is positive, but we know it's not a perfect square, then I know the square root of n is an irrational number. Here's an example. Radical 37 is an irrational number. It's not a perfect square. Left in this form of square root 37, this is giving me an exact answer. It's not approximated, it's exact. I can, however, type this into the calculator and get a rational approximation. This is what the calculator gave me. I did put the 3 dots to show that it would go on forever. This decimal will not terminate and it will not repeat, which makes it irrational. Your calculator display will probably cut the digits off at some point. That doesn't mean it's the end. That's just all that it's going to display. So if I look at the rational approximation, remember the goal of a square root is to find 2 identical factors that would multiply to 37. So since I know it's approximate, I'm going to round this decimal to the nearest tenths, which is 6.1. When I multiply them, I don't get exactly 37. So I know 6.1, that is not the 2 identical factors I'm looking for. Let's go out another decimal place. So I'm going to use 6.08. Now I'm below 37, so I have not hit exactly 37, but I'm closer. Let's go out 3 decimal places. I'm going to round this 2 up to 3 based on normal rounding rules. Now I'm getting closer. I have 37.00, but there's still some stuff lingering around here. So I did not get exactly 37. Let's go 1 more decimal place. And again, I'm close, but I'm not exact. In this example, it doesn't matter how I round the rational approximation. It's never going to give me 2 identical factors that will create 37, and that's why it's irrational. But I do know that it's bigger than 6 and less than 7. So the best option is for me to leave it in its square root radical form. So I know that the 2 consecutive integers that it falls between are 6 and 7. So keeping it in the square root radical form is the best option for us, and that's what we're going to practice today. So just a note before we get started, when you see a number in front of a square root radical, just know that multiplication is implied. That doesn't mean I want you to type it into your calculator and multiply it, but this 2 as a coefficient is going to sit there until there's another coefficient available for it to multiply into. So let's go through our rules for simplifying. The first step says I need to find 2 factors of the radicand. In this example, it's 200. One has to be a perfect square. This is the big deal. So when I multiply 2 numbers together, can I get 200? Will 4 work? Will 9 work? How about 16? How about 25? These are just a few examples of perfect squares, but one of your factors must be a perfect square or this process does not work. When you've identified your 2 factors, the factor that is a perfect square will get square rooted and turn into a rational number. And then finally, I have to keep examining the radicand. If I can continue to pull perfect squares, I need to repeat the process until no more perfect squares exist. So when you're selecting your factors in step 1, the bigger the perfect square, the better, because you'll eliminate a bunch of work. So let's treat this example as number 1. I'm looking for 2 numbers that multiply to 200. One has to be a perfect square. There are a couple different options. So I'm just going to pick one option. I know that 4 will divide in, so I'm leaving the coefficient of 2 in front, but I'm separating the 200 into radical 4 and radical 50. That's still 200. I always put my perfect square in the front. So 2 times the square root of 4 is actually 2 times 2. So this radical 4 is rational. When I multiply these together, I'm going to get 4. But I also look at 50, and I know that there's more perfect squares in there. So my whole number in front is now 4, and I've separated the 50 into 25 and 2. 25 is a perfect square, so I'm going to now simplify that into its rational form, which is now 4 times 5. And in the final step, I will multiply 4 and 5. I can see that radical 2 is as simplified as it's going to get, and my final answer is 20 radical 2. You should have done this in algebra, so I'm hoping that this is just a review. Example number 2, the square root of 18. We need 2 numbers that multiply to 18. One has to be a perfect square. Yes, I know 6 and 3 will work, but neither is perfect. So we have to use radical 9 and radical 2. The 9 is the perfect square, and it will simplify to 3 radical 2, and that is my final answer. In example 3, we have a coefficient of 1/2, and I want to separate 48. I'm trying to think like you, so I'm thinking most people select 4 and 12 as the 2 factors. 4 is my perfect square, and that is going to simplify into 1/2 times 2, and we're keeping the radical 12 for now. I'm going to multiply 1/2 times 2, but I also realize that radical 12 has 2 more values that it can be broken into. So 1/2 times 2 is 1. Radical 12 breaks into 4 and 3. 4 is a perfect square, so this will be 1 times the whole number 2. And finally, my answer is 2 radical 3. Remember, you can pause the video if you want to try the example yourself before I reveal the answer. In example number 4, we have a coefficient out front. For the radicand of 500, I want to go as big as possible. So I think the perfect square that I would like to use is 100. 100 is perfect, and it will simplify into the whole number 10. So I have 4 times 10. Radical 5 will stay intact, and my final answer is 40 radical 5. In example number 5, we're going to multiply 5 times radical 144. This example is a little bit different. Hopefully you recognize that 144 is already a perfect square. You do not have to separate this into 2 sets of radical 12. What we simply do is square root 144, and we get 5 times 12. So in this case, the radical disappeared altogether, making my final answer 60. In example 6, we're using the square root of 98. So here's what I would do. This one doesn't seem like it's very familiar. I would start dividing with the calculator, divide by 4. If that doesn't work, divide by 9. That doesn't work, divide by 16. And you're going to continue this process. Once you've gone about halfway, so once you've tried dividing by something that's around the size of 50, if you don't find a perfect square, you will not be able to simplify it. So watch for those. With the little playing around, I know that radical 49 times radical 2 will be 98. 49 is a perfect square, and it simplifies to 7 radical 2. In example 7, we have the square root of 280. When I look at it, I see 28 and 10, but neither of those is a perfect square. So I'm going to start simple. I know that 28 is divisible by 4. 4 is my perfect square, and it leaves 70 behind. So this simplifies to 2 radical 70. Now, we should determine if there's any more perfect squares that will come out of 70. But as I check, it's not divisible by 4 or 9 or 16 or 25. You can do this all the way up to this perfect square of 36. At that point, I did not find any other perfect squares, so 2 radical 70 is the final answer. All right, let's try some of these exercises. They want us to state whether each expression is in simplest form. If it isn't, we need to simplify it. That means using the new procedure, no decimal. So radical 10, there are no squares, so this is yes. Radical 64 we know is positive and negative 8. Radical 18 we just saw in the last slide. We have the square root of 9 and the square root of 2. So this is 3 square root 2. Radical 7 is very simple. It only has factors of 1 and 7. 32. I know that a 4 will be pulled from this. So we have radical 4 and radical 8. This is 2 radical 8. Don't be fooled. Radical 8 is not simplified. There's another square. This is 2. We'll have radical 4 and radical 2. So this is 2 times 2, which is 4 radical 2. In number 6, radical 99, we have the square of 9. And the other factor is 11. So this simplifies to 3 radical 11. Moving on to our next set of examples, they just want us to find the value of each. So 72 squared, that one's pretty big. On the calculator, we get 5,184. For number 8, the square root of 441, what I would do is check on your calculator to see if it's a perfect square, and it is. This is positive and negative 21. 23 doesn't simplify, so we'll leave it as the square root of 23. If you would rather put it in a decimal, there's nothing here saying that you can't do that. The decimal approximation is 4.80, and I did round this from my calculator. The square root of 62. This doesn't divide by 4. It's not a perfect square, so we could leave it as the square root of 62. If you choose to do a decimal approximation, it's 7 point, and I'm going to round this 87. Make sure you round according to their directions. Number 11, that's certainly not something I recognize. Let's see if it's a perfect square. When I type it into the calculator, I do get positive and negative 54. And then the last one, 14,400. This one happens to be a perfect square, so we could have positive and negative 120. This is homework number 110 in your packet. Where it says use the table on 566, we're going to disregard that. We're just going to use our calculator. So state whether each number is a perfect square. Simplest form means leave it in a radical. Simplify means leave it in a radical. When you get to the next section, you can use a calculator. That's okay. Please show the work in the white space or on the back of that paper. And the second portion is just calculator work. If you have any questions going through this assignment, please contact me somehow. I'm happy to answer any of your questions. And until then, have a great day.